Good day, ladies and gentlemen. This is the 15th lecture of the second series of lectures related to the implementation of the RM software for filter design. It is about synthesis of Alll-pass network, which approximate a group delay characteristic around a frequency located somewhere on the frequency axis, so that they are all pass from the amplitude point of view, but they are band pass from the group delay approximation point of view. The specific feature of this program is that the group delay is approximated in maximally flat sense, and that it allows for approximation of constant group delay and linearly rising and linearly falling group delay. The content of the presentation is, as usual, the naming of the project is first, then introducing the design requirement, synthesizing the transfer function, analysis of the properties of the solution, and finally realization, which may be passive LC, active RC and active SC, and digital infinite impulse response realization. We will start by activating the main program RM1 and allowing the blocked content, and then we will go to the slide which describes the planning of the design. So we first enter the project name, and since we are going to bandpass filters, we are entering the design requirements for bandpass filters. And then we do use the B10 software, B10 program, which will perform the synthesis of the transfer function that will allow for the complete synthesis of the system. We will use Cascade AP for the passive, and the rest is as usual. Let's start the design by introducing the project name. It will be bandpass Alll-pass. Note the underscores. Now we will proceed with Alll-pass synthesis. We have to supply the design requirements. It will be 100 kilohertz. We will use here 100 microseconds as a nominal group delay. Then we will use negative slope for -10%, and normalization resistance of 1 kilo. That will be all. And now we may proceed with transfer function synthesis of a bandpass, Alll-pass, constant, and linear group delay. We need to supply the order of the filter, and we will put 10. Note now that the quantities such as the order of the filter, the nominal group delay, the slope, of the group delay are interrelated and limited by the area under the curve of the group delay. It may happen that you supply data which are not physically realizable, and in that case you should proceed either by increasing the value of the nominal group delay which is suggested in the program, if that happens, or by decreasing the order of the filter. Now let's run. This program accepts the values we supplied, but since it runs iteratively and it needs time, we will pause the recording. The iterative process finished. We will proceed now with the synthesis of the transfer. We will proceed with the analysis of the temporary results, and that will be the CSV file. Here it is. We will stretch a little bit the frequency axis to 200 kilohertz. What we are looking at now is the relative error of approximation of the group delay, which converges outside of the approximation interval to 100%, of course. Then this is the phase characteristic. It's difficult to see that it is parabolic in the passband. And this is the main information. So this one is the required value of the group delay. This is the absolute error, and this is the group delay. Now we will proceed with the synthesis. We will go first for passive solution. It will be Alll-pass cascade AP. Done. Now we will look to the SPICE file first. We will go for the group delay, and we will change its minimum value from 90 to 110. Of course, we should enlarge this, and we can see the slope here and the error done by the by the conversion from the mathematical function into the circuit is about 400, just below 400 microdecibels. It is less than half of a millidecibel. Now we will go for the schematic. It is a 10th order filter, which means it needs 5 second order cells. 1, 2, 3, 4, 5 second order cells. Okay, now we are going to the RC cascade. Done. Let's see the spice file first. Here is the group delay. In this case, we have even lower error introduced by the physical realization of the amplitude characteristic. It is about 20 microdecibels. Okay, let's see the schematic. So it needs five cells realizing the Alll-pass circuit. Okay, now we will proceed with the switched capacitor, with the RC parallel. The RC parallel finished, we will go for the spice file. So we have the group delay here and a very, very small error introduced by the parallel realization, which is again about 20 microdecibels. Here is the schematic. Now we have 5 second order cells in parallel, the summing, the details of the summing circuit. We proceed with the switched capacitor solution. It asks for the sampling frequency and for the normalization capacitance. And we will proceed now with the synthesis. Okay, let's see the spice file. So it's probably one occasion now to show that the spice file is rather complex, not only because of the cells, but also because of the switches. As you can see here, there are so many switches inside, and each of them is supposed to be controlled by the set of signals which are coming from the sample and hold, and have switching frequency too. We will look only for a moment at the signal which is coming out behind the second stage of anti-aliasing. Here is the schematic, which is similar to the parallel, and here this is the zooming, the anti-aliasing, the sample at whole and the system. Now we will go for the digital. The sampling frequency will be 10 megahertz. And we may proceed with the synthesis. Since there is no SPICE file, we will look to the CSV file. Okay, this is the phase characteristic. This is the gain. This is the group delay. And this is the amplitude characteristic in decibels in logarithmic scale. As you can see, the values say that we are about 100 of a decibel, the error. It was already advised, and this is a moment to repeat, that all these files were created during the synthesis, and when this finished, the designer is advised to copy them in a separate directory and to have them as a documentation, temporary or permanent, depending on the situation. So in this case, we may decide whether our approximation of the group delay is satisfactory or not, or if satisfactory, we will finish, or if not, we may restart the design. So thank you very much for your attention. That was end of this lecture.